Let's recap what we've done here. We have this approach, this 6-step approach to hypothesis testing. One thing I skipped over in the last video, and I just want to mention here, is that please notice that you have to have a simple random sample. It has to be that n times p times 1 minus p is greater than 10. Remember, that ensures normality. We learned about that in chapter 6 and then again in chapter 8. And it have to be independent. Okay, so if you don't have that, then you can't do anything. But we're assuming most of the time we have those things. All right, then you made your hypotheses. Like in our case, we were trying to show it was rigged against the African American defendants, so we chose left-tailed. The proportion was too low. We selected an alpha. Most of the time that's going to be given to us, but this time we wrote it ourselves as 0.001 because we didn't want a high chance of making a type 1 error. We found our test statistic, right, which was negative 8.05. You can use a calculator, use whatever. Actually, I'm going to show you a faster way in a minute, but if you're on the test or whatever, you can use your calculator and just type it in. And then we have the classical approach, which is what we did. So we found our critical value. We drew a picture. And yes, you're going to have to draw a picture when you do these problems by hand. You draw a picture, you shade it. That was alpha over there. So this is negative z alpha we're finding. It's this middle picture right here. So we found that with Excel, with a table, with whichever. And then since our z0 was less than that, we rejected the null hypothesis and stated our conclusion. And that's what we did right here. We also made a note over on the side just for our own benefit that x was equal to 4. They didn't give us x in this problem. They gave us p hat right there. Sometimes they'll give you x. Sometimes they'll say there were only 4 African Americans. Then you use 4 over 80 to make your p hat. This one actually gave us p hat, so we just used it. All right, so that was the classical method. But I actually prefer, and you will too, the p-value method. Why? Well, for a lot of reasons. One is that the p-value method has a very simple rule. Because p is your probability of getting what you got by random chance. What are the chances of that 5% just being a fluke? You know, hey, they just had 5% African Americans that day. What are the chances of that happening by accident? That's what your p-value is. You're going to determine it using technology of some kind. And then if it's lower than alpha, you reject. Done. If it has a low chance of happening, that's too unusual to say it happened by accident, and you reject the null hypothesis. That's all there is to it. Okay, so we're going to determine the p-value, and we're going to do this with technology. You have to do it with technology. So, well, you don't have to, but the table's yucky. And we are totally going to use StatCrunch for this. Like I said, we're going to use StatCrunch for pretty much everything from here on out. Okay, so I'm going to open StatCrunch here, and I've got my StatCrunch. Oops, right here. I'm going to open it in a new tab. So here it is. Oops. I want to go to stat. I want to go to proportions, one sample. Now, if I had data, if I had like a list of different answers from people like, yes, I'll vote for this person, no, I won't for this person, etc., then that would be with data, which is really never going to happen for us. We're going to be always working with a summary. So click with summary, and you wait. There it is. So it's going to ask you, what was the number of successes? Now, this is why we needed to know the x value. That's what x is. X is the number of successes, the number of African Americans in that room. So in our case, it was 4. You have to find it if it wasn't given to you ahead of time. Round it to the nearest whole number because it has to be a whole number. So if they had given you, I don't know, 3% and it came out to 3.2 people, you'd round to 3 people, round to the nearest number. And there were 80 people in the pool altogether, so you go 80. Right? So x over n. The top number's x, the bottom number's n. The two of them together make your p hat. Click next. And it's going to say, okay, what are you trying to test? Well, we were trying to test against the null proportion of 0.5. Hey, that's convenient. It's what we wanted, 0.5. And then the alternative for us was a less than. So we pick less than. And then we click next. I don't care about that, so I'll just click calculate. And there it is. You just copy and paste it right into Excel. I'm telling you, this is the easiest thing. We're going to be doing it all the time because StatCrunch just finds everything for us. We don't have to work nearly so hard. It doesn't find the critical values, so that's the thing about the classical method that is not as nice. But it finds the p-value stuff right on. So you can see here, let me zoom in just a little bit. All right, you can see there's the test statistics. So if you didn't find it with your calculator, you could just read it right off of here. Heck, we could have done that from the beginning, right? So you can see, oh, there's the 4, there's the 80. That tells me the sample proportion. That's p hat right there, p hat. So if we didn't have that figured out ahead of time, we could have figured it out right then and there. Standard error, whoop-de-doo. And then it tells us the p-value is really small. It tells us it's less than 0.0001. Really small, right? Okay, so computers, calculators, whatever, sometimes they'll say that that's 0. They'll write it as 0.000. StatCrunch is better about it. They're actually just letting you know it's less than 0.0001. It's really, really small. Okay, so you just take that and say, okay, that's my p-value. Oops, let me get out of here. What is it really? I actually found it for the heck of it, just so you know. I wanted to write it up. So you can just say it's the p-value is 0.000, or you could say it's less than 0.0001. Fine. Good. Marvelous. It's a really small number. Okay. Some computer programs will write that as just 0. They give up. Calculators in particular just give up. They call it 0.00 and done. They don't want to look at it. Okay. So what does that mean? And you got to draw a picture again. So let me go back to the thing we are always going to be using to refer to for ourselves. We want this left-tailed picture. Now notice, by the way, these are not the same pictures. Over here on the p-value side, if you look at that bottom edge, it's z0 down there. z0 being what we found up here, which was negative 8.05. Over on the classical method, it's z alpha, because that area is alpha. Over here, the area is the p-value. See it? They're not the same thing. You got to draw what they give you. So if we're doing the p-value method, this is the one we're doing. So we draw a curve. We put our z0 down. Now, for us, our z0 is so low, it's off the screen, right? So that was the regular one. This was the classical one. But down here, it was negative 8.05. Think about that. That's 8 standard errors away from the mean. It's really far. So you've got to draw a curve that goes to 8 standard deviations. And the area in that little bitty tail, according to Minitab, is 4.139 e negative 16. Which is really, 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 really small. As a matter of fact, I wrote it out with all the zeros. Because it's 15 zeros and then a 4. Right? Now, we all agree that whatever it is, if they tell you that the p is less than 0.0001, that is less than our alpha, right? And since it's less than our alpha was 0.001, only 2 zeros there. So since it's less than our alpha, we are going to reject. That is the p-value method. It's the same idea. So if you were asked to do the whole thing with the p-value method, you do the same step 1, same step 2, same step 3. You could maybe use StatCrunch to help you with that part. And then you would skip 4 and 5 and do this 4 and 5 instead. And then step 6 would be the same. It would be, there is enough evidence to support the claim, blah, 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 blah. All right? All right. So computer programs, StatCrunch isn't doing this. They're saying sometimes some computer programs listed as 0.000. Minitab will do that sometimes. Or sometimes they'll say, like you saw in StatCrunch, just less than 0.0001, right? So you have to know that it isn't really 0. It's just close to it. If they say p is less than 0.0001, you have to know that this implies it's smaller than 0.001, right? So because if it's less than, this is 1 out of a 10,000, then that's certainly smaller than 1 out of 1,000, tenths, hundredths, thousandths place, right? So this is 1 in the thousandths place. This is 1 in the 10,000ths place. So that is much smaller than this one. All right. We just saw the two methods side by side, so let's look at it again. I drew the curve. I drew it really huge, right? So because I got to get that 8 in there. All right, so with 1, we had the 8.05 and the 4e negative 10 kind of going out, and it's so tiny you can't even see it on the screen. And then with this one, we had the 3.09 and the 0.001 right there. Okay, the classical method compares the z-scores, right? So the classical method looks at 8.05 and 3.09. And that's what I wrote. Oh, at least I should have written. Uses alpha. Hold on one second. There we go. The classical method compares the two z-scores. Is this z0 farther away than z alpha from the center? Right, that's the classical method. I.e., are you really far away from the rest of the group? Just like Steve, we knew his die was loaded because he was far away from the center. Z-score was really big or really low. The p-value method compares the areas, the p-value and the alpha. If the p-value is less than alpha, we reject. Done. And again, the p-value is the simpler one because for p-value, you're always looking for low p-value, right? Looking for low numbers. So how do these compare? One thing to keep in mind is that if you reject H0, the null hypothesis, with one method, you're going to reject it with the other. You cannot do it so that you reject with one and do not reject with the other. If you do that, you've done something wrong. So you can always check yourself with the other method. In particular, we use the p-value method to check ourselves a lot because calculators and computers do the p-value method, okay? Because it's simpler for calculators. Both methods have similar graphs, but they're not the same because one graphs z0 and the p-value. One graphs alpha and z alpha. They're not quite the same. In this particular example, z0 is way farther away than z alpha was. Right? It's really on the same curve. It's just different portions of it are shaded for the two different graphs. The classical method uses alpha. I just said that. Alpha or alpha over 2 is the area in the tails. And the p-value method uses that p-value that comes from the computer and z0. So they're slightly different in picture, but they'll get you the same answer one way or another. It's just you know it's loaded or rigged because of one method, or you know it's rigged because of another method. But both should work. Which brings me to my next point. There are a lot of p's floating around, and I don't mean the green kind you put in stew. So there's p0, p hat, and p-value. So P0 is the null hypothesis proportion. It's what we assumed to be true. In our example, it's 0.5. So we assumed that the proportion of African Americans on that jury was 0.5, just like it should have been. Okay, so that's P0. P, got a little letter P right here, is the population proportion. We don't know what it is. We assume it's equal to that null value of 0.5, but we don't know. It's the African American percentage on that jury panel in our particular example. But in general, it's really the African American percentages on all jury panels in that area, or similar jury panels. Similar jury panels, because it's not really just about this one case. It's about how it would work in all cases. But suffice it to say, it's the population proportion. And again, that's a parameter that's unknown. It's about the population. We only know our sample value down here. So our sample proportion was given to us as 5%. And then we figured out that was 4 out of 80. Now, I warn you, sometimes they're going to give you the 4 and the 80. Sometimes they're going to give you the 5% and the 80. You've got to figure out which one they're giving you. But that's your sample proportion, p hat, which was 0.05 in our case. And then we have our p-value. That's the probability of it being a fluke. That's the chances that this was 5% just by accident, just, because. So it's the probability of p hat being where it is by random chance, i.e. fluke, right? What are the chances just by accident? We ended up with 5% that day, but it was still fair, right? That's what the p-value is. That's what you found. All right, we're going to have to stop right there, and we'll pick back up here for a little bit more about p-value and what it means. I'll see you then.